Hey guys, welcome to Digital Srini channel on YouTube, and this is one of the videos as part of our tips and tricks series. And as you may have noticed, these videos are released on Mondays, and typically I answer your questions if I see a trend in your questions as part of this series. So keep an eye on these ones on Mondays, and in addition I schedule my regular videos for Wednesdays, as you probably know. If you are not a subscriber, please go ahead and hit the subscribe button right now. In this video, I'm going to talk about understanding the keras-trained model. Like, you train your model and then you save it. What information gets saved, and can you actually have a look at how the structure of the saved model looks like by opening a hdf file using a viewer. So if this is of your interest, let's go ahead and continue this video. If not, I really recommend continuing this video because you may learn something new from this, especially if you are using Keras. If you are using some other framework, I'm not sure how much useful this video is going to be because the structure of the saved model is probably different depending upon your framework. So this is definitely appropriate for the ones who are working with Keras. So let's jump in. So we can clearly follow a path, follow a structure. I'm going to use an example from video 228. This is where we trained a UNet for aerial imagery segmentation. Again, it doesn't matter. You can load any hdf5 file, whether it is classification or semantic segmentation. The process that I'm going to show you is going to be pretty much the similar. So this is more of a understanding type of video rather than just going through line by line of the code. So I'm just mentioning this in case you're a regular viewer of my channel, you know exactly what file I'm talking about. So we trained a model using a simple UNet, and as you can see, my UNet has a convolution block with two convolution layers and a dropout and max pooling, con max pooling, and then we are going from 16 to 32 filters to 64, 128, 256, and then back to 128, 64, and so on. This is a classic UNet, and as part of your expansive path or decoder path, we are going to do some concatenation operations. And as you probably know, our conv layers and conv2d transpose layers are trainable. They have trainable parameters, but the dropout and max pooling, of course, they do not have trainable parameters. All of that hopefully will make sense once we print out the model summary and also once we open the saved hdf5 file. So we use this to train a model. So and I saved that model as hdf5 file or h5 extension. It doesn't matter. We saved the model using model.save in Keras. Now, a few months later, I'm back at looking at this. I'm like, okay, what information can I get out of it? And can I go ahead and load this model and do other tasks? So in order to do that, let's go ahead and write a few lines of code here, which I did. So because we have used Keras, I'm going to use TensorFlow import Keras. And in fact, let's go back and see how we imported Keras right there. Did we do? So here I did, this was from a few months ago. And I directly imported keras.models, and now I'm using from TensorFlow import Keras. And something different. This is the new way I taught myself to be a bit more organized. Just get everything from TensorFlow. Okay, so from TensorFlow, let's import Keras, and you probably know that to load a model, we have to, we can just do keras.models.load model, and this is the model that I'm trying to load, right? This is the one that I saved on 7th May 2021. So let's go ahead and try to load this model. I said try because it's going to throw an error, as you probably, some of you know. The reason it is throwing an error is because it doesn't know what this dice loss plus 5 focal loss is. What is that? Well, it's throwing that error because in the model that it stored from 7th May 2021, it has some information about dice loss plus 5 focal loss. In fact, this was the loss function I used while training the model. So it's saying, hey, I don't know what this is. Give me that information. So obviously that information did not get stored in its entirety as part of the models, because it's not going to store that specific function that I defined. So you need to have access to that. And that function that I defined back in the day a few months ago was, I hope I can find it right here. Yeah. So this is the function. So I'm using dice loss, focal loss, and I combined dice loss and focal loss with a multiplication factor of 5. That's exactly why it said 5 focal loss. But you need to know this. You cannot open someone else's H5 model file and automatically expect to understand exactly what in the world this is. So it makes sense if you appropriately label your functions right there. So let's try this one more time. So here I am importing my dice loss, my focal loss, and I am adding my dice loss and focal loss with a weighted average of, weight of 5 to my focal loss. And I defined this as my total loss. So let us go ahead and, by the way, I'm importing the dice and focal loss from a library called segmentation models, but that's immaterial. Whatever the function you used in the past, go ahead and do that, right? So let's go ahead and import this. So now I know that my total loss is what it means when it says dice loss plus 5 focal loss. So I'm going to copy that parameter. And as you probably know, when you load models, any custom objects that you define, you can actually define that as a dictionary right here when you load the model. So I'm defining my dice loss plus 5 focal loss is nothing but my total loss. Yeah, that's the total loss. So now let's go ahead and run this model. When you do that, it should fail again because I have another custom object called Jacquard coefficient, because that's the one that I have used as part of my, no, where is it? Yeah, as part of my metrics right there, because we are compiling the model with optimizer information, with loss information, and with metrics information. So it needs to have all the information about these three. It knows what Adam is because that is coming from keras. I'm not writing a custom function. If you have written a custom optimizer, then you need to provide that too as part of your custom objects. So again, we are trying to unravel what's stored as part of the saved model. Of course, loss is saved and also the metrics. So it's saying, I don't know what you mean by Jacquard loss. So tell me what it is. So that's exactly what I'm trying to do. So from this model that we just defined, in fact, there is a function called Jacquard coefficient that I defined as part of this Python file. So let's go ahead and import that. Go ahead and import Jacquard coefficient. And now as part of my custom objects, in addition to dice loss plus 5 focal loss, I'm defining Jacquard coefficient as this. So now this should hopefully work without an issue. And now we loaded our model successfully. So we loaded the model in its entirety. So let's go ahead and print out the summary. And if you look at the summary, this has all the information right there, right here. The layer name, how many filters, and how many trainable parameters, all the information is printed. Because we are using this API for model.summary to actually print this out. So basically, it's extracting the summary information from the loaded model. That means our model, the hdf5 file, had this information or still has this information stored in it. We'll again open this hdf5 in a minute and then just see exactly how the information is stored. Now, because this is stored, we can also, we are actually bringing, looking at the model, and we are extracting relevant information. So if you want the layer names, right? I mean, here the layer names are input1, conm2d, dropout, conm2d1, max pooling. These are all the layer names. If you just want to print that out, you can just say from model.layers gives you all the layers, and from each of these layers, go ahead and print the name. That means in each of these layers, it is not just storing the name, but it's also storing some other information. But we are printing only the name here. So it does make sense for you to understand what other information gets stored. So first of all, you can look at Keras documentation to understand this, but a better way of doing that is to just open hdf5 file, get familiarized with what is stored, what exactly is stored in there. So let's do exactly that. And before jumping into opening that, I just want to quickly address what hdf5 is in case you don't know what that is. This stands for hierarchical data formats. And this is a great documentation. I mean, go ahead and Google search for what is hdf5. You'll find a million hits and find the one that you think is appropriate for you. I'm looking at something called Neo neonscience.org, and apparently they put together some documentation that I happen to like about hdf5. So it's a container format. If you just want a simple answer, it's a container format that actually stores a lot of information in a very hierarchical way. So you can see there is a group, and within that group you can have another group, and then metadata, and so on. As soon as we open hdf5 file, you'll realize exactly what this means. But I just want to give you a quick overview of what that is. And to open the hdf5 file, go ahead and go to hdfgroup.org, or just Google search for hdf viewer or hdf view, and download it. You need to register with an email, but once you do that, go ahead and download it for your operating system. I downloaded the Windows 10 version right there, installed it, and now let's go ahead and open it. And this looks like a bit of an old Windows 95 or 97-ish look, but that's okay. It does exactly what we want it to do. So let me open the hdf5 file that we just looked at. So that was this file, 7th May 2021. Let's go ahead and open it. So let's start from here. First thing first, if you click on, you can open multiple hdf5 files right here and then navigate through them, but let's focus on only one for now. Let me click on the title right there on the main link of the hierarchy. As you can see, it starts right there. Within that, you have two subdirectories, if you want to call that. Again, this is a container, and if I go back, those two are, think of these as these groups. And in each group, you have some metadata associated with that. So let's get back right here. So you have model weights and optimizer weights. These are the two groups that you have here. Right away, I would say maybe you can ignore optimizer weights. Actually, let's park that topic for a second. Let's go ahead and click on this and see what information is here. First of all, it stores the information about your backend. I believe that means, is it TensorFlow or not? Yeah, there you go. So it says, okay, you're using TensorFlow backend, and when it comes to Keras, what Keras version are we using? 2.4. So the model here got trained on Keras 2.4. So it does have the information about your Keras version and model configuration. This is important. So what is the configuration of your model? Let me bring this to the middle. And when you double click and open, it's tough to see anything. Let's go full screen. There's a lot of information here. This is basically the model structure. You see the class name config, yeah? And when we did model.layers, this is what it's looking for. Layers is a dictionary right there, you see? Model.layers. Within model.layers, we are looking at layer.name. So if you go all the way and look at layer.name, you see how it says input1 right there. So the first name it looked at was input1, and if we go back to our code, that should be the first name right there. And then it looks for the name tag again, and then it'll find con2d and so on. So you can extract all the information that you're seeing on the screen right here. Sorry. Let us go back to this. You can extract any of these, like how many filters and what type of data type is it, and what is the name we already looked at. So all of this information is available, and you can export this. I think you can export this into a text file and go ahead and just get familiarized with exactly what information got stored. So let's move on. So that is model configuration. You can look at training configuration. So training is how obviously, as the name suggests, it's a training configuration. So this is the reason why it gave us that error when we tried to load the model, because it was looking for training configuration and it was trying to find dice loss plus 5 focal loss, and it couldn't find it. So it threw an error. Then we supplied that, then that made it happy. Okay, and let's see, it was looking at accuracy. What else is there? I don't want to read every little thing from here, but I just want to highlight a couple of, again, the Jacquard coefficient was another error. We supplied it and it made it happy. And Adam, it figured out, and the learning rate for Adam, this is the learning rate that it was using, and it figured out because Keras knows what Adam is. Keras doesn't know what Jacquard coefficient is, especially the way I named it. And here are the beta 1, beta 2, and other parameters that Adam was using. So you can extract all of this information programmatically. Of course, that's the easiest and best way to do that. But we are, again, in the process of understanding what information gets stored as part of your hdf5 files. Okay, so this gives you the structure of the model, right? This is the structure. So if you import it without any weights or anything, then this gives you the structure. Then you're good. But you want the weights. When you're doing transfer learning, you want to load the weights. And how are the weights stored? There are two things that you'll see here, model weights and optimizer weights. And I would say if you just want to use your model for just predictions, then the optimizer weights doesn't make any difference. I mean, you don't need to worry about it. Optimizer weights is basically the state of the optimizer. And if you look at it, we have Adam, right? That's the optimizer we used. And as part of Adam, you see all the layers that are trainable. You will not see any max pooling here, any concatenation, nothing. These are all the trainable layers where the optimizer, think of this, like I said, as the state of the optimizer. And these are the weights that are used as part of your training process by how much the weights need to be incremented. Remember, this is the optimizer. So this is optimizing your weights or updating your weights as part of your training process. But once the training is done, then this is usually, I mean, this is not useful anymore. Or you can just discard that. This is used as to assist your training process. Okay, so that's enough about optimizer weights. Now let's look at model underscore weights. And you can import all of these weights when you're doing transfer learning or part of these weights and so on. It arranges these not based on, or let's go ahead and print the model summary. It arranges that not based on the structure of your model. Like, for example, it doesn't put input one, it doesn't put con first and then drop out and then con max pooling. I think it sorts these alphabetically. You can see C's, D's, and I and M. It just arranges them alphabetically. It doesn't matter. When we import them, then as long as you have the right names, it should be imported the right way. The weights need to be can be imported the right way. Now here you see all the layers, including the concatenation, including max pooling right there. So you see all of these. But when you open the concatenation, there is not much there. Okay, there is some information, but not much information over there. But if you have convolution layers, for example, conv2D, I believe this is the first layer. Let's move this a little. Conv2D, this is the first one, right? So that's the name of the first layer. So let's go back and open this conv2D right there. Open the conv2D. And when you open that, you see there is bias and kernel. How many biases do we have? 16. That tells me this conv2D is corresponding to right there, conv2D, 16. Again, initially 3 channels. That's why you cannot import a trained model weights that got trained on RGB images into to train your grayscale images or multi-channel images. I did a video on this topic in terms of how to do transfer learning on different channel images and all that. But you see, now it makes sense, hopefully. The weights that you have here, if you look at input, let's go ahead and look at the input channel, not input, where is it? Conv2D, the first conv2D. We have 16 weights, right? 16 filters right there. And each filter, you know that these are all 3x3, right? 3x3 kernels. Again, if we go back to our multi-unit model, these are all 3x3 kernels. Meaning I have 9 weights, 3x3 kernel. And let's open this and look at our kernel now. So when I open the kernel, let me bring it to the middle. You see 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have these 9 right here. And let's go ahead and open this for some layer, I don't know, conv2D4 right here, conv2D4. And when I open the bias, it shows 63. That means it's one of these conv2D4, conv2D4. It's probably that one with 64 filters right there, because we have 64 biases. How many weights do you have? You have 3x3 times 64, that many weights. So if we go back and look at kernel, the number of weights is basically showing us these many weights right there. So let's come back, and again I have to understand why, because I said 32 right there, because you see how you have 31, 0 to 31, so that means it has 32 weights. It has 32 weights, so it's actually showing me that for number of weights and this for number of biases. I have to think about that, sorry about that, but again, I'll probably leave that in comment if any of you figured that out, why there is a lag between weights and number of biases. Please leave that as part of the comments. I cannot think while I'm recording the video, sorry. If you look at COM2D5, let's go ahead and look at this. This hopefully should have 64 right there. You see the number of weights right here are 64, and each is a 3x3 matrix, which we know. That's the 3x3 kernel size. So if you keep going, these are all the weights. These are all the trained weights. So when you load the weights, this is exactly what it is trying to import. So these are all the weights right there. Okay, and this is COM2D5. Let's go back here, COM2D5. Yeah, it's a mystery. I'm not sure why COM2D4 was showing me. Let's go back. I hate to troubleshoot while recording a video, but COM2D4, right? So COM2D4 was showing me 32, but when it comes to biases, it's showing me 64. It beats me at least while recording the video. But let's go through a couple of these. And now if you look at dropout, there is nothing right there, because dropout, we are not training them, so there are no weights associated with dropout. So if you say, hey, go ahead and import weights, you'll see an empty list right here. But when you import weights from the COM2D or COM2D transpose layers, then you'll actually get a list that is populated with both bias and kernel information. Okay, so I am thinking if there is anything else. I don't want to make this video any much longer than it needs to be, but I think this gives you a very good understanding of how to at least open and study your HDF files, the hdf5 or h5 files that you saved as part of your keras training. Let me go ahead and stop right here. Again, I'm tempted to do that troubleshooting. It's not troubleshooting. It's just basically understanding why it is storing with a lag right here. If I figured it out by the time I publish this video, which I'm hoping tomorrow, which is Monday, October, I forgot, 3rd, 4th, or one of those days. But please leave. I know a lot of smart people watch these videos, so if you know exactly the reason, leave that as part of the comments. Thank you very much, guys, and keep watching these videos, and let's learn about these things together. Thank you.